Hey guys, in the following videos, we are going to discuss how server components work by going through a simple framework that I have created. This framework and the videos are an attempt at understanding the currently experimental server component APIs, as we don't have any official docs from React as of now, so take this with a grain of salt. In this video, we'll cover server component concepts on a high level to get a rough understanding. In the following video, we'll cover concepts regarding streaming by going through some code. And in the last video, we'll be going through the code of the framework to get a better understanding. So let's get started. Before getting into server components, let's see how the world looked like before it. We could use React in two ways. First is a client-only approach. In this approach, we have a client, mostly a browser, and server to fetch static files from. When we load any particular route in the browser, we'll get an HTML file. So this is an empty HTML file with no content, and we have the div with root ID where our React application will eventually be injected. Next, we fetch the client bundle. So this will contain our entire bundled React application. This is how the entry point will look like. We create the root and render our main component. Now finally, once the client bundle is loaded, usually next we would like to fetch some data from server. So we do that using API calls and get the data in JSON format. So this is how a basic client-only flow looks like. Now let's talk about the limitations of this model. Firstly, client-server waterfalls. We need to make multiple round trips before we show something meaningful on the UI. Secondly, as the app grows in size, so does the bundle size. And this can cause delay in fetching the JS bundles on a slow network. In the second way, we can use React in server-side rendering to render any component to HTML. So let's see how it works. Again, we have our client, and when we load a particular route, but this time we don't get an empty HTML page. At least the user is able to see something, but it is still non-interactive. This is how a very simple SSR setup might look like. The main thing to look out for is the render to string method exposed by React DOM server. What it does is, given a React component, it converts it into HTML string. After receiving the HTML, we still have to add our React magic to it. So we load up the React bundle next. That is the client bundle. So this is how our entry point for React app looks like. Difference from the client only approach is that we'll use hydrate root instead of create root, and we'll hydrate the same component that we rendered to HTML on the server. So what hydration means is that whatever dry HTML we received from the server, React will attach event listeners, load hooks such as useState, and eventually take over control. Next, if you want to load some additional data, say on some action, we still have to rely on the client-side request to fetch the data in JSON. Now let's talk about the limitations of this model. Just like we discussed, SSR is applicable only for the initial HTML of the page. And if you want to show new data on the same page, for example, we want to show a modal on that page without having to reload, we'll still have to rely on the fetch calls to show the content of the modal. Secondly, as our app bundle grows in size, since the entire app needs to be hydrated, it can take some time before things are interactive. Let's now finally discuss server components. Server components are rendered on the server. Before going into how the client-server flow looks like, let's discuss some new things that we can do with server components. So server components can be asynchronous. That is, we can use async await inside component. This is helpful to add data fetching in component itself, because mostly data is closely tied to UI anyways. Whatever async components we have, we wrap them in suspense so we can show fallback until they are loaded. I will explain what I mean by that with the example of rendering a server component. In this example, we have a delayed hello component that waits for 1 second before displaying hello world. Next, we have the main component, which wraps the delayed component in suspense. Now we'll render the main component, and let's look at how the output RSC stream or payload looks like. You can see the API that we are using is render to readable stream. We'll be going into detail about what these APIs are in the later videos, but for now we can say that a component is being rendered to some sort of stream. If you are not familiar with what streams are, simply put, we can compare streams to downloading a file. We don't receive the entire file at once, but we receive it in chunks. Similarly, when we create a stream, we are essentially creating chunks of data. Again, we'll be covering streaming in detail in the next video. So let's look at what the render response looks like. This response isn't readable, but let's try to make sense of it. And let's only focus on the important bits as we don't need to understand everything. If we look at the main component, the first child is the div. Comparing it to the response, we can see our div element, and this object represents the props passed to it. In our component, div only has children prop. So we can see the children contains a value of $1. If we look closely, $1 is pointing to React suspense. So it seems to me that dollar signs with numbers represents references to certain values. The suspense component props include the fallback component, which contains the paragraph element that shows the loading text. And the child of suspense component is the delayed component, which seems to be $L2. Now it's not present in the first chunk, but after 1 second, we'll get the chunk 2. Now in the chunk 2, we can see it has 2 as the key and the paragraph element rendered with hello world text. The $L2 in suspense contained a reference to this chunk value. So what React will basically do is, it will replace the $L2 with this new chunk value when it will consume this response on the client. So this is how rendering a component looks like in server components environment. Now let's look at example where we also have a client component. So we have hello client component, which receives message as a prop and displays it in a paragraph tag. The p tag also has an onClick method which shows an alert. Now all of this is specific to client environment. It is indicated by the use client directive at the top. Next, we have the same delayed hello and main components. The only difference is that delayed component renders the hello client component and passes the message as prop. In the render to string method, we also need to pass client manifest file. We'll look at what info it holds in the later video, but for now, it is just a JSON object which stores the information about the client components and their paths. Let's look at what the response looks like. Chunk 1 looks similar to what we had in the previous case. After 1 second, we'll get the second chunk. We can look at the second key in the chunk 2. So it contains $L3, which is pointing to our client component, and we pass message as a prop to that component. If you look closely, message was actually rendered on the server as it is a part of server component. If you look at the third key, it represents an instruction to load up a client bundle, which will contain our hello client component. So when the React will pass this response on the client, it will fetch this bundle. So this is how we can compose client components with server components. Now let's see how the client-server relations will look like in the server components model. We have two cases that we need to consider, one with SSR and one without SSR. As we saw, SSR only relates to how the initial HTML looks like, so we can either include it with server components or not. First, let's look at no SSR case. So we make a request from client and then we get the empty HTML file. It looks the same as in the case of client only. Next, we load the client bundle. Now in the client bundle, we'll make a request to our server to render the component to RSC format that we saw earlier. And once we get the server rendered response, the client can now update the UI. So this is how the flow looks like with no SSR case. Here the disadvantage is that we are not showing user anything until we load the client bundle and get the RSC response. So now let's look at the flow with SSR involved. In this setup, we have a client, a SSR server, and a RSC server. Firstly, we'll make a request for a particular route to SSR server from the client. Then SSR server will forward the request to RSC server and we'll get the RSC stream, or also called as RSC payload version of the component that will match the route. Now on the SSR server, we'll do two things. First, we need to convert the RSC payload that we received from the RSC server into HTML stream. This is important as the user can at least see some HTML content. Now, we'll attach the same RSC payload chunks to the window object. These chunks will be later used for hydration purpose on the client. In reality, we'll actually have the payload as an array and we'll look into how to handle it in the later video. So we have these two formats of the same component. One is HTML stream and one is the RSC payload attached to the window object. Now we stream the HTML back to the client from SSR server. The HTML stream will also contain the client bundle that we need to fetch. So we'll get that next. Once we get the client bundle, We can immediately start hydrating the component with whatever HTML stream that they have received. And we'll use the already rendered RSC payloads from window object to hydrate the HTML since it represents the same thing but in RSC format. Finally, for subsequent requests for new data, we can fetch the response directly from the RSC server and get our server rendered output. And once the client receives the response, we can update the UI accordingly. So this is how the entire flow looks like. And these were just high level concepts. In the later video, we'll go through the code base as well. Thank you.